We will continue now what we started in the previous video. So we will talk about flags. Flags is just a variable, a Boolean variable that can contain values true or false, and we can use this value to check in the if condition. So imagine we have a Boolean value x, a variable x, and the value is false. We can write if x. If x means if it's false, we will not do the condition. If x is true, we will do the condition. So we have something else called logical operators. These operators are used to combine two conditions like and, or, and not. So we use them to create relational expression. Okay, so for this and, both condition has to be true to get it true. For this or, if one of them is true, it's enough. This not, it has to be false so that we can go to the condition. For example, if int is equal 12, y is 5, z minus 4, this Boolean expression evaluates to true. Why? Because x is greater than y, this is true. Y is greater than z, this is also true. So both are true. True and true is true. This is false. Why? X is greater than y is true, but this is false. If one of them is false, then we get false. X is less than or equal z, this is false. X equal z is false, so both are false. False or false is false. This is false, but this is true. False or true is true. X is greater than z is false, but we have not before, so not false is equal to true. So we can use this in the if statement. For example, we can write if employed, the variable employed is equal y, and recent graduate equal y. In this case, I can do you are qualified for the loan. Otherwise, I just say you are not qualified. I can also write or, if your income is greater than the minimum income and the number of years you have in employment is more than minimum of years, you can get the loan. So here, if any of the condition is correct, you can get the loan. Okay? Otherwise, you get error message that you should earn at least this or have experience at least this. In this example, if not the income is greater than the minimum income or the years greater than the minimum years, so if you, these are the condition for the loan. If you don't have this condition, I make you error message. Otherwise, I write you qualify. So here I make not to reverse the condition. I can also use not. So anyway, if you have more than condition, more than operator, so the not has the highest precedence and followed by and then or. So we can check the number range using these operators. For example, I can say if the grade is greater than 0 and the grade is less than 100, then I can print this is a valid grade. Or I can write if the grade is less than 0 or the grade is more than 100, it's invalid grade. So I can check the range using these operators. Remember, in C++ you cannot write something like this. If 0 less than or equal grade, which less than or equal 100, this does not work in C++. It works in Python, I think, and also to work in mathematics notations, but does not work in C++. So in C++, if you want to write something like this, you have to write if grade is greater than or equal 0 and grade is less than or equal 100. So the menus, in programming sometimes you have menus. When you run the program, it tells you please press 1 for this, 2 for this, 3 for this. This is called menu driven programs. Okay, so the menu is just list of choices on the screen. We can implement this menu using if else. Maybe you have this before in Python. So the menu, we display a list of numbers or letters, choices for action. We ask the user to enter 1 for this, 2 for this, and so on. And then we ask the user to enter, and we test the expression. If it matches one of the codes, we take the action. If not, we go on to the next expression and check. So validating user input, we can also use if else to validate the user input. For example, to check if the user enter a correct. For example, we ask for a grade. We can use if else to check if he enter a correct range of the grade or reasonable values or reasonable menu choices, or if we want to divide by 0, we want to make sure if he did not enter 0, if we want to divide by this number. So this is just one example for the validation. So we ask the user to enter a test score, and then we check if test score is A, we print A, otherwise if it's greater than B, we print B, and so. Then we write else, your grade is F. So all these, we validate them by minimum score and maximum score. So if the test score is greater than the minimum score, which is 0, and less than the maximum score, let's say it's 100, so we do this. Otherwise, we go outside the validation and we say this is invalid score. Okay? So we can use if else in the validation. We can also compare characters in C++. When we compare A and B, we will convert each character to the ASCII code, and we see which code is before. So in this case, A is less than B, because the ASCII value for A is 65, while for B is 66. 1 is less than 2. The character 1 is less than 2, because the ASCII for character 1 is 49, while for 2 it's 50. Usually the lowercase letters has higher ASCII code than uppercase letters. So A small is greater than Z capital. So here in this example, we ask the user to enter a digit or a number or a letter, sorry. If the letter was greater than 0 and less than 9, so if the range of the ASCII code of the character that the user enter between these two, we will tell him you enter digit. If it was greater than A and less than Z capital, we said you enter uppercase. If it's greater than A small and less than Z small, we write you enter a lowercase. Otherwise, we say this is not a digit or a letter, what you entered. So same like ASCII code, we can also compare strings. For example, if string name 1 is Mary, string name 2 is Mark. Okay. So name 1 is greater than name 2. This is true, because Mary Y is greater than K. So M is same like M, A is same A, R is same R, but Y is greater than K. So this is true. The opposite is not true, it's false. Okay. And they are not equal. This is true, because they are not exactly the same string. We can also say name 1 is less than Mary Jane, because Mary Jane has more characters. So name 1 has only Mary, but Mary Jane is greater than it if we compare strings, because it's have more characters. For example, we can use something like this. If Bart name is a string, is equal to this string, then we will print the price is whatever. Else, if the Bart name equal to this string, we will print something else, and so on. Otherwise, we will print this is not a valid Bart name. So there is something called conditional operator. Conditional operator is another way to write if else, a shorter way. For example, you can write x less than 0, then you write question mark. If this is the case, then you write y equal to 10. Otherwise, z equal to 20, semicolon. This code, simple code, is similar to writing if x less than 0, then y equal to 10, else z equal to 20. So just a short way to write if else. If you find it somewhere, you just understand this is another way to write if else. So this is the condition, and this is the what happens if the condition was true, and this what happens if the condition was false. Okay, so the value of the conditional expression is the value of the second expression if the first expression was true. This is same like what explained. And the value of the third expression if the expression was false. Sometimes we use parentheses, like if you want to make this expression in some situations, you make parentheses to force some operations to be more important than others. This is just an example of the conditional operators. So where we are using conditional operators, so we are asking for hours here, to user to how many hours you worked, and here's depends on the hours he. If the hours is less than minimum hours, then we give him minimum hours. Otherwise, we give him hours. So imagine the minimum hour is 5, okay? So if he works less than 5, we give him 5, this is the rule. If he work more than 5, we give him the number what he worked. So whatever he work, he should work at least 5. That's why we make this condition. If hours less than minimum hours, hours will be equal to minimum hours. Otherwise, hours will be equals to hours. Okay? So this is just another way to write if else. Switch statement. Again, switch statement is another way to write if, else if, else if, else if. Sometimes you like it, sometimes you don't like it. You just use else if. So how we can write switch? You write switch, and here you write some expression. Usually it's integer. And then you write case. You give a value. If this integer has this value, this will happen. Otherwise, this will happen if it has this value, and so on. Let's take example. You ask the user to enter A, B, C, A, B, or C, and then we get the choice, and then we switch based on that choice. If he enter A capital, we print you entered A and break. If he enter B capital, we print you entered B capital and break. If you print C, then you enter C capital and you break. And then there is a default case. So how it's working, the switch? It's check the value of choice. If it was A, it will print you entered A and break. Go outside the switch. If you entered B, it will come to case B and print B and break. If you go to C, it will come to case C and break. If you enter anything other than A, B, C, so you can just print you didn't enter A, B, C, or C. So you can, if you notice, you can do this by if else. If choice equal A, do this. Else if choice equal B, do this. Else if choice equal C, do this. Else do this. So we can do that actually by using if else, but this is another way to do it. Maybe you like it, maybe you don't. This expression must be integer value, okay? Either character, like here, or integer. It cannot be double or string or something else. So this is first rule of the switch statement. So expression 1 to expression n must be constant integer expression or literals and must be unique in the switch statement. So the value of this must be different from this and this. This is also clear. And the default part is optional. So maybe you do default, maybe you don't, as you like. So we explain how it's working. The break things, okay, we use a break to exit the switch. So usually after every case you write a break. If you didn't write a break, then this is what will happen. So let's take this example. You ask the user to enter the model number. Maybe it's 100, 200, 300. Imagine the user enter 300. Then he will come to case 300. He will print picture in a picture. Okay. But because there is no break after this, the program will continue to the print stereo sound and to print remote control till it reached the first break. Okay. For some situation we need this to omit break, but usually we have break after every case. Okay. So as you see, this is the output. If we make 300, then it will print three things. If you have 100, just print remote control and then stop, because if 100, it's print remote control and break, and so on. So sometimes it's easier to use switch if you have menu systems, like enter 1 for this, 2 for this, 3 for this, 4 of this. Otherwise I think if else is easier. Block and scope. So scope, if you remember, we talked about scope before. Scope is the space in the program or the range in the program where you can see the variable. Usually you cannot use the variable before you define it. So we will talk more about scope. If you define some variable in some block, for example int years, you define this variable here. So the scope of this variable from here till the end of the block where it was defined. So outside this if statement you cannot see the years, because this years was defined inside the if statement. So you can use it here, here and here, but you cannot use it outside the block, or we cannot use it in the block before you define it. So the scope will be from here to here. So if you try to use it here after the if statement, it will not work. So we call them like this. Definition is local inside the block. Okay, this variable. طيب, what happens if you have int number? This variable, the scope of this variable from here till the end of the main. طيب, you have if statement, and inside this if statement you define another variable called number. So this is okay, there is no conflict. Why? Because this number is defined only here inside the block, and this number is defined outside the block. But when you refer to number here, it means you refer to this number which is local here, but you don't refer to this number. Usually it's not recommended to use the same names, even it's allowed, but it's confusing, right? Because when you print here number, you mean you print this number because it's local in this block. But usually we should not do that. We should use different names. So that's it, and see you next video.